Use Desmos.com in order to help you graph systems of linear inequalities. So last class we used Desmos just to graph inequalities and see what the graphs of those inequalities looked like. And today we're going to take it one step farther and actually graph systems of linear inequalities to get the answer to the system. So just like systems of equations, we're going to have two inequality equations that we're going to go and type in, and we're going to see where they intersect. Because just like when we solved systems by graphing and we wanted to know where the two lines intersected in order to know the solution, we want to know the same thing when we're graphing systems of linear inequalities. We want to see where they intersect. So we are going to open up the classwork, and I would split your screen so that you can see the classwork at the same time that you can see Desmos, so that you can work in both as efficiently as possible. So when you open the classwork, it's going to ask you to put in your email address, your name, like it always does. Hit next. The first question wants to know which of the following graphs matches the system of linear inequalities given below. So in order to decide, first I'm going to type both of these inequalities into Desmos so that I get a picture, and then I can match the picture to my options. So I'm going to go over to Desmos. Now you can use your keyboard to type in, or you can pull up the Desmos keyboard to type in the equation. So we're going to say, okay, y is greater than or equal to 1/2. Now in order to get out of the denominator here so that I can type in the x, I'm just using my arrow key to move over to the right. X minus 3, and I get a picture of a graph. Now I'm going to click where it said number 2 so that I can type in the second one at the same time. So now I'm going to type in y is greater than -3 divided by 2. And again, I need to get out of the denominator, so I'm using the right arrow just to move my cursor over so that I'm not still in the denominator. X plus 5. So now that I have my inequalities here, I'm going to just minimize the keyboard so I can see more of the graph. And I'm going to zoom out a little bit so I can see the picture a little bit better. And I want to see which one matches my graph. Now you'll notice that when I look at option 1, there's only one piece that's shaded. Whereas over here on Desmos, I have 1, 2, 3 pieces that are shaded. The difference is these graphs are only showing us what they share. So the only piece that I'm really paying attention to being shaded is where the red and the blue overlap, where I have this purple together, because this red shading only applies to the first graph. The blue shading only applies to the second one. So I just want to pay attention to what they share, and that's what should be shaded in my answer. So I can see, even though my lines are matching, I've got my dotted line in the same place and my solid line in the same place, the shading isn't in the right place. I need the shading to be up here because that's where the purple is. So I'm going to keep looking. All right, lines in the same place, shading not in a great place. Shading still not where I wanted it. I wanted it here. All right, shading is where I wanted it. There we go. So I'm going to click option 4. So now the next thing I'm going to do, we're going to answer the same, do the same exact thing for number 2. Number 3, same thing. Number 4, same thing. Number 5, same thing. So at this point, you should be getting really good at using Desmos. Same thing, number 6. Now, number 7 looks a little different. Number 7 isn't giving us a graph, but they want to know where the solution to the systems of inequalities is. So again, we see there are options for coordinates. So I'm going to type in the two equations and then, or the two inequalities, and then we're going to look at what could be possible solutions. So in order to get rid of the inequalities that I have, I'm just going to hit the X on both of these. Goodbye. And now I'm going to type in what I had and bring back my keyboard. I'm going to say, okay, y is greater than or equal to 2 divided by 7, move my cursor over, x plus 3. And now I also need x is greater than -2. All right, so I can see in my graph, and if you click on the graph, you can kind of move it around a little bit. I'm going to zoom in again so that I can see the numbers a little bit better. I can also always click on the line anywhere and get the coordinates to come up. So I see that my lines intersect right at -2 and 2.429. So I need to decide which of these points could be possible solutions. So a possible solution for these systems is going to be anything that's in the shaded part that they share. So it can't be a number that's just in the purple because the purple is just for the bottom equation. It can't be a number that's just in the green because the green is just for the top equation. It has to be over here in this darker area that they both share. So I'm going to look first, my first equation, or my first coordinate is 2, 6. So I go over 2, up 6, 1, 2, 3, 4, 5, 6. And I see that 2, 6 is right here, which is in the darkish purpley green part that I want it to be in. So 2, 6 is a possible answer. Check. All right, now I'm going to check -5, 4. So in order to get -5, 4, I've got to go back 5, up 4. That's only in the green, so that's no good. I can't use that because it only works for the first one. It has to work for both of them. So then, now I'm going to check 4, -1, or 4, 1. So I'm going over 4, up 1. Only purple. That's no good. My next point is 7, 5. So I'm going to move my graph over a little bit. Going over 7. So here, up 5. Right here. Even though it lands right on the line there, that still is going to count because it's still included in the green, and all of this over here is already purple, so it hits green and it hits purple. So even if it lands on the line, because this is a solid line, it counts. Now, if I had landed over here on the line, like say I had the point -2, 5, this one, even though it lands on the purple line is dotted, so it doesn't count. It has to be a solid line in order for that to count. Because we're saying we can get really, really close to -2, but x can't be -2. It has to be greater than it. So if the point lies on the line that's dotted, it doesn't count as a solution. But because 7, 5, again, over 7, up 5, lies on the solid line, that counts as the solution. So I'm going to go 7, 5, definitely. And then my last one to check, 0, 6. So over 0, up 6. That's in that dark area, so that's good as well. You're going to do the same thing for number 8, number 9. And then number 10 looks a little bit different. Number 10 gave you the graph, and they want you to pick which system matches the graph. So you're just going to graph each option. So you're going to go in and type in y is less than -3x plus 4, and y is less than 1/2 x minus 4, and see if you get the same graph as this. If you do, that's your answer. If you don't, not your answer. So then you try the next one. All right, I think you're ready to rock and roll.